Chapter 5 is all about atoms and the process of bonding. In order to understand bonding, the most important element to understand is that of valence electrons. Valence electrons are the electrons that have the highest energy level on an atom, and they are held the most loosely. The number of valence electrons in an atom is what determines many of the properties of that element, including the ways in which that atom can bond with other atoms. Each element that we will discuss has between 1 and 8 valence electrons, and we can represent these valence electrons in something called an electron dot diagram. You will sometimes see it referred to as a Lewis dot diagram. The electron dot diagram includes the symbol for the element surrounded by dots that represent how many valence electrons one atom of that element contains. For example, hydrogen has 1 valence electron, so we represent it with a capital H, its atomic symbol, and its 1 valence electron. We always begin on this side of the symbol of the element. Carbon has 4 valence electrons, so we will represent carbon with 4 valence electron dots. Again, we begin on this side, and then we travel around the symbol, putting 1 valence electron on each side. We would not number them. The numbers are simply to show the order in which we draw them. Finally, oxygen has 6 valence electrons. We would begin here, putting 1 here, 1 here, 1 here, 1 here, and then we continue the process again. A second and finally second round there, meaning that now we have a total of 6. You may be wondering if there is a shortcut to figure out how many valence electrons an element has. If we didn't have a shortcut, we may have to simply draw all of the energy levels every time. For example, element number 33 is arsenic, represented AS. And when we go through the energy levels, we see that it has, since it's 33, we know it has 33 protons in the center, and then following the rules we know about energy levels, we know the first has to have 2 electrons. The second energy level can have 8 electrons, meaning so far we have a total of 10 of the 33. We know the third energy level can hold 18 electrons, which means now we're at 28, but that leaves, in order to get to 33, 5 extra. So in the case of arsenic, it has 5 valence electrons. But this process is pretty inefficient and would take a really long time if that was the only process we had to figure out if there were valence electrons. Thankfully, there is a shortcut. Atoms are more stable or less likely to react when they have 8 valence electrons. Atoms usually react in a way that makes an atom more stable. Number 1, the number of valence electrons increases to 8, or 2 for hydrogen. Or atoms will give up loosely held valence electrons. And here comes the shortcut to find out how many valence electrons an atom has, so that we don't have to draw that diagram every single time. The way that we find them out is by examining the groups. So, remembering that groups are vertical columns, we can see that the elements that are in group 1 have 1 valence electron. The elements that are in group 2 have 2 valence electrons. Now, here's the important part. All of these elements here in the center, we will simply ignore and move in to the column that begins here, 13, but really we will think of it as column 3. So, group 13, right, just subtracting the 10, is going to have 3 valence electrons. Group 14, subtracting that 10, will have 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and finally 8 valence electrons, in exception to helium. And the reason why helium is stable is because it only has 2 electrons, which means that it only has the first energy level, and it is full and stable with 2 valence electrons. We will use this information to help us as we learn about how elements bond, either ionically or covalently, as we continue to explore chemical reactions.